let z1 be equal to a plus bi and z2 be equal to x plus yi. Work out an expression for the modulus of the product of these two complex numbers in terms of the mod of z1 and the mod of z2. So let's work out the product first of all. We do that in the usual way when expressed in Cartesian form, and if we multiply that lot out we get this expression with the final term being by I squared. And we can remember that I squared is equal to -1. So if we make that modification and then collect the real terms and the imaginary terms, we end up with this. And then to work out the modulus of the product, we can do that in the usual way. So in other words, we take the square of the real part plus the square of the imaginary part and then square root the lot, having added them up. If we multiply out each of those squared brackets, we end up with this rather long algebraic term, all still within the square root. But notice that we've got a term here and a term here that cancel out. So if we remove those, we can then actually pull a squared out of x squared plus y squared, and we can factorize out b squared from x squared plus y squared. So we've got another common factor here, and then we can group the a squared and the b squared into another single bracket. So our expression becomes the mod of z1 times z2 is equal to the square root of a squared plus b squared multiplied by x squared plus y squared. So we can separate these out into the product of two separate square roots, and then that has proved that the mod of z1 times z2 is equal to the mod of z1 multiplied by the mod of z2.